this is lesson 51 for 7th grade, and today's topic is scientific notation for large numbers. Now, scientific notation isn't anything, well, we have seen it before. It's nothing that we should get too worked up about, because it actually is a pretty simple concept, and we'll kind of review the whole idea behind scientific notation. And today we're only going to talk about large numbers. In the future we're going to talk about scientific notation for very small numbers. But today we'll focus on large numbers because it's the easier way to get into it. Okay. So here it says, the numbers used in scientific measurement are often very large or very small and occupy many places when written in standard form. For example, a light year is about this large number here. So we've got hundreds, thousands, millions, billions, trillions. So we've got 9,461,000,000,000 kilometers. So very large number. And when we're working with a lot of large numbers all at once, it's kind of hard and a little tiring to write out all the numbers this way, especially if we're going to rewrite them a whole bunch. So scientific notation is a way of expressing numbers as a product of a decimal number and a power of 10. Okay, so in scientific notation, a light year is 9.461 times 10 to the 12th power kilometers. Okay, so it's a different way to represent it, because as we've seen before, multiplying by a power of 10 moves our decimal to the right. So if we had 3.5 times 10 to the second power, that's really 3.5 times 100. And 3.5 times 100 equals 350. And all we did there was move our decimal over 2 spots to the right. So we took our 3.5, moved it 1, 2, our decimal's here now, and it's 350. Okay? So what this actually means, the example that we're looking at, this means 9.461 times 10 times 10 times 10 times 10 times 10, 12 times. Or when you look at it, we're just moving place values. So if I check this, we start here, I should be able to move it 12 spots and end up at the end of this number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Took me 12 moves to get to the end there. So that's how they knew this would be 10 to the 12th. That 12, or 10 to the 12th, means we're moving our decimal 12 spaces to the right. So it's a different way to write that very large number, basically. If you went through and actually calculated this, it would come out to this answer, if your calculator fit that on its window, which I doubt it does. So a lot of times our calculators might show us some answers like this, and I'll show you at the end here some different ways you might see them pop up. Okay. Here's kind of a list, and shows us a length. Towards the end, we have standard form and scientific notation form. One thing we do need to point out is that we want our first number, or whatever we're multiplying by the power of 10, we want all of these numbers to be between 1 and 10 or less. Okay? So notice here, we made sure that this number here, 9.461, this is less than 10. We don't want the numbers to look like this. Oops. Yeah. We don't want it to look like this. This number is less than 1. This number is greater than 10. So we want this first number here, we want this to be greater than 1, and then, oops, greater than or equal to 1, but less than 10. So it can be 1, but we want it to be less than 10 for sure, and 1 or greater. Okay. So standard for scientific notation is this number is less than 10, greater than 1. And you can see that here. All these numbers are between 1 and 10. Yeah? Yeah, this is just a chart. And I pointed out here, notice that the exponent does not indicate how many zeros there are. Okay? So this doesn't mean there's going to be 1 0. It means we're moving our decimal over 1 spot. Or here, we're moving this one over 2 spots. But notice that there's only 1 0 here. It does not tell us how many zeros there are going to be. Sometimes it might, but it's actually telling us how many spots to move our decimal over. Let's look at this one. 1.1, we're moving it 5 times. 1, 2, 3, 4, 5. So we get 110,000 millimeters. Okay? So, just to point that out. Okay. Let's take a look at this example. There are 8.64 times 10 to the 4th seconds in a day. Show how this number is written in scientific notation. Okay, so 8.64. 8.64 times 10 to the 4th seconds. Rounded, okay? That's how we would write that in scientific notation. That one's pretty straightforward. It kind of tells us how to write it. Okay. In scientific notation, the power of 10 indicates where the decimal point is located when the number is written in standard form. Consider this number expressed in scientific notation. As I was showing you earlier, it says multiplying 4.62 by 10 to the 6th has the effect of shifting the decimal point 6 places. Yep, so note the exponent is 6 to the right. We use zeros as placeholders, okay? So, they show you how to do this, kind of like I was doing before. We'll move it 6 spots to the right, as they did here. 1, 2, 3, 4, 5, 6, okay? And whenever there's not a number, we fill it in with a 0, okay? So, there should be 6 numbers beyond the number 4 when we're done, and there are. There are 1, 2, 3, 4, 5, 6. Okay. But basically, just in the basic form, this says we're moving this decimal 6 spots to the right. So 1, 2, 3, 4, 5, 6. Okay, I'm going to erase that. Right, 2.46 in standard form. Now standard form just means a regular number, as we saw in the last example. So, 2, 4, 6 times 10 to the 8th, that means we're going to move it 8 spots to the right. So, 1, 2, 3, 4, 5, 6, 7, 8. And all these get filled with zeros. 1, okay? And then we kind of put our commas in from right to left. So this equals, how many zeros we got? 1, 2, 3, 4, 5, 6. Every 3. So 246 million. Alright? Okay. To write a number in scientific notation, it is customary to place the decimal point to the right of the first non-zero digit. Then we use the power of 10 to indicate the actual location of the decimal point. Okay, so that's what I was talking about before. Excuse me. If we write a number in scientific notation, that's going from this type of number to this form. We want only one number to the left of our decimal, or how do they say it? The decimal point to the right of the first non-zero digit. That's a little confusing, but basically we want this number, like I said before, to be between 1 and 10. So in order to change this in a scientific notation to get it down into this form, we go, this is where our decimal is right now. We see how much it takes us to get back to this spot, because we want just one digit to the left of that decimal point. We want this number to be less than 10 but greater than 1. So we count how many spaces does it take to get there. 1, 2, 3, 4, 5, 6, 7, 8. Took 8 spots. So to write that in scientific notation, it's 4.057. See there, 4.057. And it was 8 spots. So times 10 to the 8th power. Okay? That's how we would write it in scientific notation. If you went through and calculated this, you would come back out with this number. So there is a way to check your answers, as always. Check my time. Doing okay. Right. 40,720,000 in scientific notation. Okay, so the decimal is right here. We want to get it to right here. Let's count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Alright, so this would be 4.072 times 10 to the 7th. Because in order to change this back into this, we'd have to move our decimal 7 points to the right. Okay? And is everything okay here? Yes, this number is less than 10 but greater than 1. And we have it multiplied by a power of 10. Okay, now let's take a look at these. Now that we can do our scientific notation, we can compare which ones are bigger. Right off the bat, we should see that even though this number is smaller than this one has one more place value than this number does. So this is actually 1, we move it 4 spots, 1, 2, 3, 4. This is actually 12,000. This one is, we're moving it 3 spots, 1, 2, 3. 2,100. So that number is bigger. Okay? Alright, we are getting close on time, but I think we're about done. I just wanted to point out once again that a calculator, when it can't fit all the digits on a calculator, it displays them in different forms. For instance, if we take this number right here, looks like 1 million times 1 million, the answer 1 trillion contains more digits than can be displayed by many calculators. So instead of displaying 1 trillion in standard form, it may use scientific notation. So this would be 1 times 10 to the 12th, or 1.0, or 1 times 10 to the 12th. My calculator, it would show this as 1e12, and to me I know that means 1 times 10 to the 12. But if you ever have a question on what your calculator is showing you, just let me know. Alright, that's all we have for today. We'll work on more of this tomorrow.